conference. You will be joined in listen-only mode.
In the next one, we talked about farming, about the example of the customer who's doing this data ingest and analytics problem and why they wanted to look at us. And we looked a little bit at what happens in the life of a software developer. So this time, we're going to talk about languages, frameworks, and the term commonly known as DevOps. I'm sure most of you have heard that term before, and many of you probably know a lot more about it than I do. But we're going to explore some broad concepts around this. And what we have teed up today is to discuss what languages mean and what frameworks mean and what the relationship is between a language and a framework. And then we'll talk about Beavis and Butthead, my two favorite philosophers other than Sun Tzu, and what they have to do with Cloud Foundry. And then we'll end the session with DevOps and then open up for a couple of questions. Fair? All right, so let's start to look and see how we start to address this. So languages and frameworks. Oops. So most of us know what a language is, right? And we've all at some point or the other worked with the usual common language mix. There was, way back, there was assembler, right? And then, closely connected to that was COBOL. And that was what we refer to as Platform 1 type languages. And I should tell you, languages really don't have much of a platform. These are just sort of the predominant languages that we used when those platforms were developed. They are still in use today, and this doesn't necessarily mean that they're bad. It's just that, it's the broad association with the technology. Then when client-server came along, we came up with C and C++ and Visual Basic and Java, JavaScript, a whole bunch of stuff like that. These are traditionally associated with our Platform 2 client-server type applications. But then, as time went on, the web revolution took over and a whole bunch of stuff happened around there. New stuff started to come on the horizon, things like Ruby, Python. And then we had, of course, Java continued on and continues on today, as does JavaScript. And then there are things which were brand new, like Erlang. And Erlang is what's called a functional language. We're not going to talk much about functional languages, but keep in mind that there's a big, interesting movement going around there. And some very modern languages like Go, which really came from the authors of C, Brian Kernighan and Ritchie were the guys who developed that. And these are the languages we commonly associate now with Platform 3. And this is not to say that these are the only languages over here. I mean, we had things like Fortran over here, which was my first language because I was in scientific computing at one point. And certainly languages like C and C++ are absolutely used in this space as well, even today. But these were some of the newer entries into this whole world of languages, right? Now, it's interesting to see what I consider a language really is. Languages should support certain types of abstractions, First of all, languages should support what's called a loop, which is while some condition X is true, do some stuff, okay? And the other thing languages also support is something called a branch or a conditional, which is if something is true, then, do some stuff. Else, do something else. So languages have loops and branches, and this basically means that certain things which masquerade around like languages like structured query language or SQL, or HTML, hypertext markup language, are not really languages. because they have no flow control in the form of loops and branches. Now, all this may seem awfully academic, and by the way, this is going to be a very hands-on kind of thing, which I'm going to do today. So please bear with me, because I'm doing most of the stuff live on this. So this is going to be a very interesting webcast, to say the least. So, you know, let's take an example of a language. Now, I happen to like something called Ruby, and Ruby is a very interesting little language. I mean, I know a bunch of languages, and I know them as for fun, okay? Now, I'm not a serious coder in any of them. I'm a hack. I do what's needed when something is quick and dirty. I do something. So let's start by writing a simple program, all right? Let's say we call it h.rb, okay, and you'll see why. And this VI, which I'm using right now, is really a screen editor. This is a very rudimentary Unix editor. I'm doing it on my Mac. And, you know, this means that, you know, there are much more sophisticated editors available nowadays, what we call IDEs. But, you know, I'll write a simple Ruby, simple program. Print hello central. All right? That's it. And I'm going to run this, and I'm going to say Ruby h.rb. And sure enough, it says hello central. Now, the formatting is not all right, so you could, you know, say, all right, let me add some stuff over here too. Oh, and I misspelled central. So we can add some formatting over here and say, add a new line over there. And then try that same program again, and there you go, hello central, all right? Now, I should tell you that this is kind of where business logic ends, right? This is what I want the program to do. So where does a framework come into all this? So let's go back and take a look at what frameworks are all about. To me, framework is more like building a house, you know? So I got a roof over here, and, you know, and I got a house here, and that's me over there, the stick figure. And maybe what I have in mind is to, you know, have a lamp with a base, and that hooks up to a power outlet, and light comes out of this. That's about the extent of what I want to have to do with electricity and this lamp over here. I'm really not interested in knowing any of the other details. Now, in reality, while building this house, some other stuff needed to happen because there was a main power supply which came in here, which ended up in a circuit board of some kind and had circuit breakers and stuff like that. And then some electrician and a carpenter and stuff like that, they carved holes through the 2x4s and laid conduit and did all kinds of wiring to bring power in here and in here so you can actually plug it in here. I do not want to know how this is done. I do not need to know how this is done. All I'm really interested in is the fact that if I have a plug and I plug in my lamp, it should work. I realize that somebody has to do this, but I don't want to be the one to do it. I want to focus on the design of the house. So in some ways, you know, what I want to do here is nothing more than, you know, business logic. This is connected with the business. This is what I'm interested in implementing. The rest of the stuff here, this is plumbing. This is what we call a framework, which is all the ugly work that has to happen before we can actually get done with what the business logic is. Traditionally, programming requires a whole bunch of work in the business logic, but it requires a huge amount of work on the rest of the stuff, and this is often called scaffolding, in fact, more in the light of constructing a large building or something like that. So in some sense, a framework is like a general contractor who builds the rest of the stuff so I can focus on the house design and what it needs to look like and its functionality. It's the functional aspects that I'm concerned with, not the technical aspects. So frameworks do work for you on the functional aspect, and we will see an example of how a framework works. Common frameworks, for example, ones that everybody has heard of, but maybe not used. The language Java describes the business logic, has a framework called Spring associated with it. And the language Ruby has a framework, its common framework is Rails, but another framework is Sinatra. And I know for the purists out there, Sinatra is not a true framework. It's a domain-specific language or a DSL, but I'm not going to get into that detail at this point. You know, Sinatra functions as a good web framework, and I'll demonstrate why. And there could be others. For example, for JavaScript, there's a framework called Node.js. Now, these are all interesting because all of these are supported by Cloud Foundry, and you'll soon see why. So let's go and look at how a framework really works and how code really works. So if you go back here, I had my Hello Central program. It's a simple enough program. Now what I'm going to do is I'm going to do something more interesting to this whole file over here. In fact, you know, in the interest of time, let me show you a program I've written, which is just called Hello. And Hello does something very, very simple. Actually, let me go back and really show you how a framework works first, okay? That is, okay, let me look at another program called HLocal, all right? So here what I do is I say, instead of just saying hello world, I'm going to have it do something else with this thing called Sinatra. Sinatra is the framework. So I say require Sinatra, and then I use some strange commands called get/do, and then I say hello world, and then I say end. Now, as people may realize, the get actually stands for HTTP GET, which means this framework webifies this application. And we'll see how it does that. Now, if I take the same program, and oh, by the way, the next one is get/info, which is the next path you'd go to, and I say, hey, that says more info on hello world, so it really lets you navigate through a website and do different things at different places in the website. So now if I say, let's run this over here. So I say Ruby HLocal.rb. Now something very interesting happens. It says Sinatra has taken the stage on 4567 for development with backup from WebBrick. And what it really has done is to start a little web server on port 4567. What does that mean? So what that means is that if I now go to a web browser, and I'm going to access this web browser in a rather strange way. I'm going to say 127.0.0.1:4527. And for those who are wondering what these numbers mean, 127.0.0.1 is the IP address for my current machine, my Mac. But it's called a loopback interface, which means I just talk to myself. I don't need an external IP address. This is how I communicate back to the machine itself. And if I do that, bingo, I get this lovely thing called Hello World. So what I've done with just a few lines of code over here, which is requiring Sinatra, and it says when somebody does an HTTP GET on the /, which is the top level for that website on that port, do the following, which is write hello world, and the H1s over here, just basically put it in bold font, and then end. Now, I've done another one called info, so if I actually go and take a look at this /info, what I get is more info on hello world. That's exactly what I had, I had in my code. So like, great, this is fantastic. So I needed to make a web version of this kind of thing, and now I have a web version of it, and I hardly did any work. All I had to do was really work on my business logic, which was saying hello world, right? So let's see what that, let's summarize what that does over here. Okay, just a second. Go to the next layer here. blank this one out, activate this one. So if you look at Ruby and Sinatra, on one hand, what Ruby does is takes simple logic and you specify that in code, which is, say hello. And what Sinatra does is it does a lot of the plumbing. And what do I mean by plumbing? Because it would take me a lot to actually do this by hand. First of all, it sets up a web server. And then what it does is it expresses the logic, which I've coded in Ruby, and then makes it displayable in HTML. And HTML, as you recollect, is hypertext markup language. And all this does is it makes it into a web page. And anyone who connects to it can now see this. And this is what's really interesting about Sinatra is, you need very, very few things to actually make this happen. There's still the open question of, hey, that's all nice and fine. You went to your own loopback interface or your own internal address and you were able to see this web page. When are we going to be able to see it out in the open world? How do you really make this an external facing application so you guys on the phone can use your mobile devices or whatever to be able to see this website? And that's a problem we'll tackle next. So all this may look fine, but frankly, to get to this point, and by the way, I worked for roughly the last 2 days in developing all of this stuff. And I can only describe it in one way. It was kind of painful. And why was it painful? Because I had to load the right Ruby. Because it was very, I needed a specific version of Ruby in anticipation of what I was going to do. And I had to load a whole bunch of gems. And gems is a term in Ruby which refers to canned packages. And I had to load gems for CF, and I'll tell you what that is in a second. It's something called bundle, which is another thing. And then, of course, I needed Sinatra, so I needed to load gems for all of this stuff over here. And to build all this, I needed a C compiler. And for those familiar with a Mac, it doesn't really come bundled with a C compiler, so I had to go and search and find, GCC for a Mac and actually build it. And this took hours. That's the only way to describe it, right? And that's a lot of work. But eventually, I liked the end result, which is I got to a very simple spot over here, and I was able to write my business logic, have the framework do the work, and I got a website. Now I got to figure out, okay, how to make it externally facing. This is, as it so turns out, a problem which is very elegantly solved by Cloud Foundry, and I'll show you exactly what happens here. So we can kill Sinatra, and that web server is done, and we're finished. Now, in the interest of time, once again, I've written the code, so I'm going to now show you what the code looks like. And if you notice that the code looks almost the same, other than this strange statement in the beginning which says class, hello, and then this little left arrow, Sinatra base, and there's an extra N at the end. So what I've done basically in technical terms is I've converted this piece of Ruby code into a Sinatra-based class. And what that means is that I can do a whole bunch of stuff with it, which we couldn't do before. Now what I'm going to do is something very interesting. I'm going to take this application, and last Saturday I got myself a free trial account at Cloud Foundry. And what this lets me do is take code as I write it, and it lets me run it on Cloud Foundry. So I could say CF push, and don't worry about what these things do. Effectively, CF is the command for Cloud Foundry, and I have some configuration files which already specify what it is that it does. So this basically takes this and it takes this program and it moves it up. And if you can see over here, it's binding a certain website to this program. All right, and now it uploads the program itself to Cloud Foundry. And you'll see in a couple of seconds that once this is done, it will actually start to build the application and environment over there. And it will start it for me. And this is very powerful because remember all the stuff that I said I had to do by hand, which was installing Ruby 1.9.3, getting various gems, installing stuff called rack and rack protection and tilt and Sinatra, which I didn't even have to worry about because all I thought was I needed Sinatra, but some other things are needed. And what it does is it creates something called a droplet, and then it moves the droplet up to Cloud Foundry. And once it uploads that, it says, okay, I'm now going to move this up to Cloud Foundry. And just to remind you what I uploaded, I uploaded hello.ruby, which says Hello Central, and I can check to make sure that this app is running by doing a quick check to see which apps are running on Cloud Foundry. And sure enough, I see hello running on the URL hkcfapps.io. And now if I go and say, okay, let me do hkcfapps.io, you will see right now that I get Hello Central. In fact, if I go to the info version of it, info page of it, because I have that also, so /info, I get more info on Hello Central. Now, this is a program you guys can access. So if you go to the URL hkcfapps.io and just point your iPhone browser or your computer browser to it, you'll basically see this behavior over here. All right? Now, that's all nice and good. And, it's like, well, that's a pretty simple program. So I could stop it. And then I could say, I'm going to write a slightly more complex program. I'll show you what it does first, and then we can decide, how we actually want to, how to use it. So this new program is called Sinatra Test, or ST for short. And let me just show you what ST really does. And that's also a Ruby application. So here what I do is I create a class called SimTest. And it says hello world. It gets the, on /info, it does more info on hello world. But then I introduce another location, or a route as Sinatra calls it, /form. And what I do here is I call something called an embedded Ruby application called form. And I'm not going to go into too much detail. I'll show you what form looks like after I demonstrate the application. But now there's a get method to it, which is what happens when I get it, and I get something called a post, which is what it puts back, and you'll see how it works, and then this will all become clear, right? So there's a couple of quick configuration files I have to change because I'm changing my program from one to the other. So what I'm going to do is I have a pre-prepared config file here. And I'm just going to overwrite this one. So now if I look at config.ru, you'll find that it says my program is ST, that's in the require statement, and then it runs this class which I just defined. And the one other file I'm going to change is something called a manifest. And what the manifest does is instead of hello, which is a program I uploaded, I'm going to change that to ST, which is a new program I'm going to load, right? Now what we're going to do is exactly the same. So the changes in manifest and config tell it that ST is the new program I want to run. So I can pretty much say CF push again, and it will pick up the code for ST, and it will move it up there, and it'll do the same thing. Now, watch what it does. It binds ST also to hkcfapps.io, and then it uploads the code. And once it's done with uploading the code, it's going to pretty much build the whole thing right there. Now, I'm running this on a Mac right now. I don't care what Cloud Foundry runs it on up there. Maybe it's running on a Linux. I have no idea, no clue, and no interest in knowing whether it's Red Hat Linux it's running on or SUSE Linux it's running on. I really don't care. What I want is for it to run the way I wanted it to. So I have all these steps which I have to do right here, which Cloud Foundry does for me. So it installs rack and rack protection and Tilt and Sinatra and Bundler just like the last time. And it creates a droplet, which is an executable thing. And then what it'll do is now it'll try to go and start this application on Cloud Foundry. And it'll check it and it'll say, hey, I got an application over here. So if you remember, the application does something more. It has this forum thing in it, and it has this reply thing on it. And you can see now that ST, which is running, which is the Sinatra test, is also running on the same URL. Now, this, again, is an externally facing URL, guys. It's running on Cloud Foundry, so all of you guys can absolutely have a look at it. So if I go to the first place, well, that looks like Hello World. But more interestingly, now if I go to /forum, which is a new thing I introduced, and this is thanks to Greg Cuss. He pointed out to me that Paz is actually the name of a company that makes Easter egg coloring kits. So in case you're ever wondering what Paz is, this is it. But this one has a twist, which means I can actually interact with this. So say I type in barf, and I submit it. Now we come to our two favorite philosophers, Beavis and Butthead, and all they do is basically echo back what you said, which is you said barf. Now, you could say, well, I mean, you know, is this something you pre-programmed? Not really. You could, once again, go to farm, you know, and it'll come back to the form, and maybe this time I say dork, and I submit it, and now Beavis and Butthead say dork. But you get the picture, right? What this means is that I can build an interactive website almost trivially inside Cloud Foundry. Now, it's not just that. I just ran one of these, right? So I can say, let me get rid of ST. So CF delete. First, let me stop it. You know, I stop my ST over here. And now if you want, I can get rid of it. And it'll ask me to make sure that I really mean it. And it'll get rid of ST altogether. So now if I do a CF apps, all I got running should be hello, and that should be in stop state, right? Now I can do, you know, CF push ST again. And it'll go through the same process again, but what I wanted to show you was how this would actually scale. And I can now start more than one of these versions, and you can imagine the headache it is if I actually start to do more than one of these, right? It's extremely painful because now I'd have to go to multiple systems and go through the rigmarole that I had to go through when I set up my own system. So once again, it goes ahead and loads all the stuff up for me, and it'll make me a running copy of this. And now I can stop this if I like. And start it again, except this time what I'll do is I'll say minus instances 2, which is start 2 copies of it. I got one of them running. I think I have some kind of syntax error there, but no worries. I'll demonstrate that to you guys later. But the fact is, once again, this allows you to be able to scale applications as trivially without having to create a whole bunch of stuff. So this is really the whole world of what do we mean by, DevOps. So we saw the pain that you go through when you try to work out these details over here. If you now look to see, okay, is this a systemic problem? And it turns out that almost in every environment you have this kind of an issue. And you have to work through to see, how do I really work through this? So if I look at DevOps, first of all, DevOps is not a product. It's not a process. It really starts at its heart from the customer. And the customer gives us some requirements, and the requirements go into development where somebody actually writes the code. And the development process produces software. Once the software is ready, that then goes into production, into operations. So you can see where the connection is. That's where the term DevOps comes from. And ultimately, the operations convert this to a service. And the service gets connected, gets used by the customer, and the customer likes it or doesn't like it and gives back more requirements. So this is a cycle which we call DevOps. That is from the requirements to development to operations. Now, operations may have a whole bunch of things like release management, or it may have other stuff like scaling, like we talked about, or it may have stuff like load balancing. Because that's the other thing you have to worry about is as you have more copies of this application running, you need something to be able to see them all and something to be able to function, which distributes the load. And this is also something which is done internally. So that's what operations guys have to do. And there's a series of other things they have to do as well, like monitoring and stuff like that. So in Cloud Foundry, what happens is, you start with what's called a stem cell. And that stem cell is what I gave my manifest to. And it said, okay, what do you want to do with that stem cell? And it installs all the software which is needed. After figuring out what the dependencies are in the software, for example, Rack was needed for Sinatra, and I didn't specify that, but Cloud Foundry is smart enough to figure out that I need Rack as well. And this was a trivial project. In comparison, a complex project may have 10, 20, 30 different gems which you have to install, and all the dependencies for them, and Cloud Foundry figures it all out. So in effect, what it does is it transforms the stem cell. And now, one might say, well, if I don't want to run Cloud Foundry, how do I accomplish the same thing? Because the problem is real. We do need to go from development to operations, and we absolutely have to be able to do this as effectively as possible, regardless of whether you're running on the cloud or not. So internally, a lot of products have cropped up, and I'll talk about one specifically called Chef. And Chef is often associated with DevOps, but I've got to remind you, DevOps is not a product. DevOps is the discipline which involves collaboration between people. It involves the convergence of process around how you do development and operations. And it involves, a collection and exploitation of various kinds of tools to be able to do that. So what does Chef do? Chef has a cookbook. And what the cookbook has is recipes. And you pick a recipe, and you specify a build from it. And this is really what makes Chef work. And then Chef has a central database of all allowed recipes in the cookbook, and the recipes are very similar to the kind of stuff that Cloud Foundry did. But the difference is that Cloud Foundry has all this built into it, and Chef is usually done inside the data center to manage this. You can also use Chef to manage a cloud. The same kind of hassles occur. It's one thing to just go ahead and get a VM, but then it takes a whole bunch to customize it. Cloud Foundry does more than just the installation of the software. Under the covers, it's already taken care of finding a VM, finding a server, finding the storage, finding the network connections, doing the load balancing. The entire enchilada is covered by Cloud Foundry, and this is what's very interesting. But the whole idea of DevOps is a pretty elegant one. What it depends on is something which says, you know, what Chef guys will tell you, it's infrastructure. As code. So just as we treat applications as code, what Chef says is, why don't you treat your infrastructure as code? Start with something vanilla, and then customize it with a recipe, and that basically gives you your recipe, your infrastructure which you want to run this on. And what Cloud Foundry does, which is even more interesting, is it makes it portable, which means I can actually take my Ruby application that I wrote and I ran it on Cloud Foundry, but I could also have another instance of Cloud Foundry on Amazon. Actually, that's what I really wanted to do this weekend, was to go to Amazon, but I found it easier to just work off of the free account on Cloud Foundry. But I could move that whole application from running on Cloud Foundry on to running on Amazon, and I'd have exactly the same effect. Okay, so that's pretty much what I wanted to cover at this point, guys. We're at almost 5:40. So let me kind of open up the lines and ask for any questions. I do want to be mindful of your time, and we'll try to wrap up as quickly as possible. But I'd love feedback. You know, do you like seeing demos? Is this like too much gobbledygook? I know a lot of the content is somewhat technical, but I want you to, at a high level, understand the broad picture of what all these things are. Just to recap one more time, we started out by saying, let's look at, you know, languages, frameworks, and now you understand why I'm talking about Beavis and Butthead. We went through different types of languages and where they stood in the grand scheme of things. Platform 1, Platform 2, Platform 3. What makes a language, what aren't languages. And then we talked some about frameworks, about building a house and the stuff around it, and Java, Spring, Ruby, Rails, and Sinatra, and you know, Node.js for JavaScript. And then we looked at the example with Ruby and Sinatra, that you could code your business logic, very simple logic in Ruby, and Sinatra did all the plumbing. This is kind of the relationship between a language and a framework. But I still had to go through a lot of pain. I had to find the right version of the software, load a whole bunch of stuff. I had to deal with loading Cloud Foundry and Bundle and Sinatra, and then find a compiler. It took hours of work to get this to work. And we still were left with the problem of how do we make it external facing. And then finally, after seeing how Cloud Foundry would automate all that for us and scale it, we looked at the world of DevOps to see how do you go from requirements to development of software to operationalizing to form a service. And we looked briefly at Cloud Foundry and Chef. Okay, so that's the summary for today, folks. That's all I had. So let's get the line if I can. And any questions? And *6 will get you off of mute for those listening. Any questions? Any feedback? Can anybody hear me? Anybody talk? *6 and let me know if you're able to get through. Hello, anybody out there? Oh, Okay, somebody just texted me saying that they start sync. Okay, I hear somebody on the line.
Yeah, hey, Lepori Joint, you have to go to the Citrix or the unmute yourself from the web console.
Oh, really? This is bizarre.
Yeah. Anyway, I posted a quick question on the comments, and a few other people had comments online. Cloud Foundry, my understanding, is allows us to deploy to all of these different platforms without rewriting. How much work? It seems like it would be a ton of work to rewrite a piece of code from Amazon to something else. Do we have any indication of what percentage or how much time it would take?
Oh, go from Amazon to Cloud Foundry?
No, I guess I'm trying to determine. We want customers to use Cloud Foundry so they can be independent. If they go ahead and code to Amazon, which would be bad for us, versus coding to Cloud Foundry, and they wanted to move, do we know how much that takes?
Okay, so let me clarify a few things. Typically, what people do at Amazon Web Services is they use Amazon as infrastructure as a service, not platform as a service. So what that means is that what Amazon does is basically provide people a container to run their operating system on, and then the customer is responsible for everything on top of the operating system. So they would give you a container, and you would install whatever, Linux on it, and then you'd install all these packages that I was talking about. And then you write your application, and you run it using all the software that's been installed. So once you've written your application code, be it in Ruby or in Java or in whatever framework you like, most of it should be portable with virtually no effort onto Cloud Foundry, because what Cloud Foundry does is it removes all the dependencies on the infrastructure as a service. So I would say very little change, maybe a few percent. Take something out of Amazon and run it on Cloud Foundry. Because Cloud Foundry is platform as a service. It's a different topic. Mike, does that answer your question? Mike?
I'm sorry, Karthik. Somebody else. It's hard to hear. Someone else has gone unmuted. Sorry.
Okay.
I think what you said is I thought Amazon had a platform as a service, and if you do code to Amazon, you are stuck on Amazon.
No. Amazon, the virtual machines are what are called Amazon machine images, and that is proprietary to Amazon, and you can't move them out. But I can take my code out, my business logic out with the framework, and I can move that to Cloud Foundry without any major issues. Does that make sense?
No, but don't worry about it.
Service that I know of. I mean, Cloud Foundry runs on Amazon as a service on AWS, but as such, anybody else on the line know?
Yeah, Karthik, this is Brian, and I guess I would state it also that if I wrote a generic C program, that program would run on anything that can understand and run the C program. So although the virtual machine that's in Amazon happens to be a proprietary virtual machine, I could take that C program off of the Amazon, C program interpreter and bring it to one that's local, and it would still run. Much like in VMware, you can take a virtual machine that doesn't care about the underlying infrastructure. It always sees the exact same thing. So what Karthik is saying is that you can take that code that belongs to you, the C program, and you could take it out of Amazon and put it onto a VMware run, code interpreter, and it's no problem. But you couldn't take the virtual machine itself. That is proprietary, if that makes maybe a little more sense.
Yeah, that's correct. I mean, Brian put it more eloquently than I did. If I've written code in Java, I can take the code out and run it on Cloud Foundry with virtually no modifications. On the other hand, what I cannot do is take the virtual machine on Amazon and move that to another virtual machine somewhere else. That's hard, because that format is proprietary. The web services APIs to manipulate that are proprietary.
Yeah, I guess I was talking about the scaling functions of Amazon, where you can, say that my application's running out of gas. I want to instantiate 3, 4 more. The data services APIs that I believe we're masking. So Well, I understand the infrastructure as a service. I was talking more about the platform as a service.
Yeah, I do not believe that they have a platform as a service, Mike, but I will check. Maybe my information is dated. I don't believe they offer anything as platform as a service at this point.
Hey, Kartik.
Yes?
This is Seth. I think what Mike's referring to is things like Amazon has DynamoDB, which is their version of a NoSQL database. If you use all those services, then you're locked in, and it's really hard to get off when you're not doing standards-based thing like you're talking about.
Correct. If that's what you're referring to, yes, you're right. Then it's virtually impossible to get out because they are very proprietary. Their Elastic Block Service or Dynamo, any of those kind of things are totally out of the question. What I didn't show here, guys, in my Cloud Foundry demo was attaching external data sources. I'll be happy to do a webcast where we actually connect to a MySQL database or a SQLite database. And we can actually, put that also on Cloud Foundry. Cloud Foundry supports certain data services out of the box. Amazon supports ones which are proprietary. Ours are open source. So, yeah, you're right. If you're tied into any of the Amazon services themselves, data services themselves, then yes, you're pretty locked in. Don't know any way to get that out. So, yes, you're right. Any other questions, guys? And I apologize. I don't know what the hell's going on. I'm going to try one more thing, *4. Yeah, I don't know what that does, but any other questions? We just managed to kill everybody. Mike is still out there. Say something.
Yeah.
Yeah, I can hear you. Okay, all right.
I'm somehow bouncing on the Cisco controller between muting and unmuting, so I don't know how to tell you what to do there.
Yeah, I got to figure out a more reliable way. This should work easier than what I'm doing right now. I apologize, guys. I thought it was a pretty straightforward thing to mute and unmute, but it's not. All right, last call, guys. Any questions? And by the way, please, any email feedback, anything else would be really, really helpful to me. If this is too deep for people, I get it, but I thought it was important that you understand conceptually what this is. I know some of our sales counterparts, might find this information a little too technical, but hopefully they got something out of the basic flow of what this does, and I'll be open to feedback from there as well. All right. Unfortunately, this is stuff that we have to do. I just got a message from Smithy saying that AWS does have a platform as a service. It's called Beanstalk. And I have not heard of any Beanstalk users, so it's possible that if you're on Beanstalk, that also will give you portability. Okay? All right. Okay. All right, guys. If that's it, then thank you very much for participating. Once again, the goal is to make this as effective for you as possible, so please give me feedback. More or less, I can go into a lot more detail. If just the SEs want to really understand how I wrote the Beavis and Butthead application, I'll be happy to. And if you want to incorporate any other data sources in it, we can work through that as well. All right?
Thank you.
All right, folks. Thank you. Take care. Bye.